Today we will continue the discussion that last day we are doing, mainly the logic design with programmable arrays. Now, today we will see that the logic design with PLAs. Last day we have seen that mainly the programmable arrays or programmable array logics can be constructed by defining two planes, the AND plane and OR plane. The AND plane generates all the product terms, and the product terms are fed to the OR plane generates the output. We discussed this particular example and we have seen how the how it realizes the different output expressions. This is the overall structure of AND plane and OR plane. That particular example, this should be the realization. Now, what we are discussing, that alternative representation of the AND plane and the OR plane. See that here that AND plane, if it is a if it is a n variable input, what we have seen that if it is a n variable input, then the number of columns of AND plane, number of columns of AND plane equal to 2n, and the number of rows of AND plane or the distinct or the number of distinct product terms. So, this is for my AND plane. For my OR plane, the number of columns are the number of outputs, say m number of outputs. The number of rows are same, it is the distinct number of product terms. So, these are same. So, now if we can represent this thing a alternate way, say these are my 4 variable input. So, if the inputs are say A, B, C, D, then actually this is the A input and this is A complement. Similarly, B, B complement, C, C complement, like that, and D, D complement. See, here the number of product terms are only 4, because there are 4 AND gates are given. So, these are my 4 rows, means that 4 product terms, and there are 4 output, because there are in the OR plane there are 4 columns. So, these are say W x, Y z, these are my outputs. So, these are my outputs, and these A, B, C, D are my inputs. Now, if I take a particular example, then see what this circuit realizes. Say again, if we see that this is my A, B, C, D, then the first AND gate output or the first product term, that P1 equal to, this is A, B. Then the second product term P2 equal to, this is A bar, B bar. Third product term is C, D bar. So, P3 equal to C, D bar. P4 is P4 equal to C bar, D. Now, if we represent the 4 outputs are W x, Y and Z, then what will be the W x, Y, Z representation? The W will be W equal to, see these are in one column. If 2 cross or 2 1 exist, means we have to consider these 2 product terms P1 and P2. That means, this is A B plus A bar B bar, which is nothing but A x naught B. X is, see x is P3 P4, means C D bar plus C bar D, which is nothing but C XOR D. Y is, so there is no Y, similarly there is no Z, because the product term here, there is no product term is selected. So, Y and Z is not there. So, that means here there are only, for this circuit there are only 2 outputs. But if say this is 1 cross is here, that means 1 1 exists, then obviously Y equal to P2 means only A bar B bar. Similarly, if one Z is Z line in the Z column, that the crosses are there in P1 product line and P4 product line, then this is Z is A B plus C bar D. So, this is the way that how we realize the logic function using PLA. Or the reverse thing we have discussed, that given this PLA is actually realizes the 4 outputs W x Y z, and these outputs are W is A x naught B, x is C x or D, and if there are some Y z are like that. So, what we have seen, that not only that one complex combinational function, but also the simple gates can also be realized by using PLA. Now, we take one example, one slightly bigger example. See, there are 6 output functions to be realized using PLA, and the outputs or the expressions are given like that. So, these are my expressions to be realized. Now, the first expression, first we study and we see that there are only 3 inputs A, B, C. So, in the AND plane there will be 6 columns and these are A, B, C, and that means A complement, A complement, B, B complement, C, C complement. These 6 columns are there in the AND plane. See how many distinct minterms are there here. See, here there are 1, 2, 3, 4, again this is common. So, 4, this is common. So, 4 minterms, and here this is common, and 3, 7, and here 4, another 4. So, there will be 11 minterms. So, now we have given some more. We see that what are the distinct minterms are there. See, first is that our first one is A, B, C. So, this minterm is my A, B, C. Second, or the product term we can tell. So, my P 1 equal to, this is my P 1. P 2 is simple A, P 3 is B, P 4 is C. Now, P 5 is A complement. This is my P 5. P 6 is B complement. This is my P 6. P 7 is C complement. Now, P 8 is C, A bar, B bar, C bar. So, this is A bar, B bar, C bar. Similarly, P 9 is A bar, B bar, C, A bar, B bar, C. Next one is A bar, B, C, or A bar, B, C bar, A bar, B, C bar. This line, this product term is A, this is B bar, and this is C bar, A, B bar, C bar. This is A, this is B, and this is C bar. So, A, B, C bar. Next is A bar, B, C, A bar, B, C. Last one is A, this is B bar, and this is C. So, A, B bar, C. So, these are my product terms. So, this is P 7, this is my P 8, P 9, P 10, P 11, P 12, P 13, and P14. So, 14 product lines are there, that means 14 rows. Now, there are 6 outputs. So, first we see that U is ABC, only one product term. So, that only P1 and that this is my U. V is A plus B plus C. So, there will be 3 cross or 3 ones. So, this is A, B, C and this is my V equal to A plus B plus C. W is again ABC. So, again W is A complement, here we see that W is A bar plus B bar plus C bar. So, actually it will be A bar plus B bar plus C bar. This will be my W. X is A bar, B bar, C bar, only one term and that is A bar, B bar, C bar. So, X is actually this is A plus B plus C, because if I take that X complement, that will be ABC. So, what we can give that X is A bar, B bar, C bar. Or X complement is what we can write, this X complement is A plus B plus C. Now, Y is A XOR B XOR C. Now, A XOR B XOR C, if we break or if we apply the rules, then it is actually A B C plus A bar B bar C plus A bar B C bar plus A B bar C bar. We know that this is actually the sum of the full adder. Now, see that how it realizes the Y. See that Y is C A bar B C, A bar B bar C, A bar B C bar, A B bar C bar and A B C. So, Y is nothing but A XOR B XOR C, the 3 input XOR. And Z is, see Z is A B C bar, A bar B C, A B bar C and A bar B bar C bar, which is nothing but A X naught B, X naught C, the 3 input X naught. So, Y and Z represents or realizes 3 input XOR and 3 input X naught respectively. So, this is one example that how a 3 variable function or a set of 3 variable function can be realized. Now, we have 2 different type of programmable array logic. One is called the programmable logic array, and programmable array logic. Or PLA, and another is programmable. Now, what is the difference between two? So far we have discussed where both the AND planes and OR planes can be programmed. That means, given some n input lines or 2 2n number of columns in the AND gate, and say the different product terms can be p, then the AND plane size is p by 2n, and the OR plane size is say p by m, where n is the number of input variable and m is number of output variable outputs. So, both can be programmed. Now, if it is restricted that only the AND plane can be programmed, but the OR plane is very much restricted, means the one output can only take a particular combination of the set of product terms, then that means the AND plane is programmed, but the OR plane is fixed, then it is called a programmable array logic, PAL. So, the difference is when both AND plane and OR plane are programmed, we call this is a PLA, and if it is, so for PLA both AND and OR plane can be programmed whereas for PAL it is a restricted design or restricted with respect to the PLA, means only AND plane can be programmed but the OR plane is fixed. So, this is this type of structure. Now, we take another real life example, that BCD to gray code converter. Already we have discussed this example and the output functions are realized in different way. Now, if there are 4-bit inputs ABCD, the outputs will be between every pair, that it will be a unit distance code, and the gray code will be, it is shown in this way. Now, so there are 4 outputs. So, if I use that Karnaugh maps for realizing that what will be my function for W, X and Y, Z. So, we will see that for W there are 5 ones, and see this is for my that K map for W. See, these are the 5 ones. That means when ABCD value are 0, 1, 0, 0, say this one, or say 0, 1, 0, 1 take. then my W is 1, then my W equal to 1. Similarly, when that ABCD is 0 1 1 1, W is 1, this is 0 1 1 0, then W is 1. In that way we can just plot the, or we can draw the Karnaugh map for W. Similarly, we can draw the Karnaugh map for X, Y and Z. Now, if we realize or if we minimize the functions, then we will get the solution as the W is A plus BD plus BC by minimizing the Karnaugh maps, X is BC dash, Y is B plus C, because we will be getting here C for that, for K map for Y, actually we are given here it is a quad. So, this will be a, so from here it will be a that A bar this is A bar, for this column it will be A bar and this is for C. Similarly, if we take this one, this quad, these are two don't cares, then we will be getting that B and C bar. Now, similarly, the Z will be getting that A bar B bar C bar D plus B C D plus A D bar plus B bar C D bar. So, now if we, so mainly that this now it becomes a very simple functions, that there are 4 outputs. So, there are 4 outputs, this is a ABCD 4 input variable functions. Now, how we can design the PLA? See, there are, if there are 4 inputs, the for the AND plane, if we see the AND plane, then the columns number of rows, the actually the number of different or distinct product terms. It can be more, but at least we need the different number of distinct product terms. Say P. Now, for OR plane, the number of rows are same P and number of columns are output will are, there are 4 outputs. So, these are 4. So, now if we see that the W x y z W is A plus B D plus B C. So, this is W, X, Y and Z. Now, what will be W? W is A plus B D plus B C. So, we see that the OR input is actually this is a 3 input OR, and this will be that A, B D and B C. These 3 product terms will be the input 3 inputs of the OR gate, whose output is W. Similarly, the X is simple B C dash. So, X will be simply B C dash. So, it will be only one line B C dash. See here, actually all possible combinations are kept, and see it does not realizes any product term. Similarly, these also. This is actually only one single input. Then it is B plus C. So, X is simple B plus C, and Z is A dash B dash C dash D B C D. So, Z is B C D, A D bar, B C D bar, and this is C, A bar B bar C bar D bar, means this is my A bar B bar C bar, A bar B bar C D bar, or C bar D. So, these will be the A bar B bar C D bar. So, Z is the sum of these 4 terms. So, this is the PLA realization or the design of BCD to gray code converter using the PLA design. Now, another array type of structure that is also programmable, that can be used for the logic design, the combination circuits, and this is nothing but a memory. So, we will see that how memory can be used as the logic design. Again, here we have seen we have taken a 3 variable examples having 4 output expressions of it, and we will see how this can be designed using a memory. But before that, we see that how the memory structure is. So, normally this is a read only memory. See that here there are some decoder lines where the decoder input are the memory addresses. So, that means, see if we write in this way, as if this is a 2-dimensional structure, again the 2D arrays. See, there are 2D arrays, and say here either 0 or 1 are kept in each element. Now, why we are calling this as a memory? Because if one is here, I can select this by taking the row and column. Say this is my, if it is a matrix type of form, say this is second row and third column. So, that means second 2 3, second row and third column, it will give a one output, the content of this thing. Now, these we are calling this 2 3, that means the position of that particular element, that we are telling as the, we are defining as the address. See, here there are, these are the addresses, and if it is a n address lines, then this will be 0 to 2 to the power n minus 1, that many number of output lines. Now, these output lines, they are called as the word line. They are, see here, this is a word line 0 0 1 1, means that here this will be treated as a 0, this will be treated as a 0 or 0 0 1 1. So, this will be actually these lines, these column lines, they are connected to a 5 volt supply, all are connected to 5 volt supply. So, this is a 1. So, this connection, if we draw, this will be like that, say as if one transistor, say one transistor is here, this is a plus 5 volt supply. Now, this is called the source and drain, and this is gate. Now, if we apply the gate as 1, then it will be connected. If it is 0, then it will not be connected, that means it is a open thing. So, see, if now this is a, that I is applied to this line is 1, then actually this transistor is on, we get a 0. Again here we get a 0, otherwise it will be a direct 1 and 1 line. So, this will be a word line 0 0 1 1. Similarly, for this word line, it is called a, this is 1, this is 0 1 0 1 0, this is a 1 0 1 0. Now, in this way we can define that the ROM structure. Now, how this ROM can be used for the designing circuit. Say this is my ROM with 3 inputs and 4 outputs. Now, this can be, first this can be realized as if it is a decoder. So, decoder input is n, the number of word lines are 2 to the power n, and this is a 2 to the power n words by m, that many number of bits, if it has m output lines. So, if we see actually here there are there are 2 to the power n by m, that many number of words are there. Now, the programmable arrays of logic gates. See that advantage of ROM is that design time is short and no need to minimize output functions. It is a very little sharing of product terms among output functions. See here that actually all the min terms or all the product terms are exist. So, there is no need to minimize the output functions, and here it is very, because all possible combinations or all possible outputs are available in the arrays, what we are calling that memory, then very little sharing of product terms among output functions are necessary, or actually it is done. Now, the disadvantage of ROM is that its size doubles for each additional input. Why? Because as there is no minimization, so for ROM actually there is no minimization So, the product terms are almost not shared. See why this is happening. See, I have in the PLA type of structure, or whatever we call the PAL or PLA, actually this is a reuse. Why? See here, if it is a 3 input, so this is a 3 input, say I have 6 such column, and what we are, why we are telling this is a reuse? Because I am taking the distinct product terms. So, that means only the product terms for, say, for all m outputs. Say if I have 4 w, x, y, z, these 4 outputs are there, then one product term can be shared by each output, and these we are calling the reuse of product terms or reuse of min terms. See that, say ABC, so this is A, B, C, this is my first product term T1. Now, W can use this product term ABC, X can use this product term ABC, Y can use the same product term, Z can also use the same product term, because the output lines are actually the columns, the vertical lines. So, they are not affected if in one row that all possible ones are there. So, similarly, say another, say a complement C, this is my say P3, this is my P3. So, a complement C can be used by again X or W. So, now in this situation the W is actually the sum of, W is the sum of the A, B, C plus A, C complement. Now, this ABC now or this P3 can be used or can be shared by X. So, now what we are seeing, that means the column one cross point or the multiple cross point in one column means that it is a sharing of the product terms. So, what we have discussed in the last class also, that the multiple ones in the or in one column in the OR plane means that particular output is the sum of all the product terms where a cross exists. But multiple ones in one row in the OR plane means that means the sharing of that product terms represented by that row. In the last class already we have discussed that one cross point in the rows in a AND plane or one cross point in the column in one AND plane means what? So, this is for the PLAs and PALs, that where both AND plane and OR plane are programmed. So, what we have seen that actually that in the AND plane or in the OR plane, that means PLAs or PALs, that only that product terms which we need or which exist in that set of particular expressions to be realized, only depending on that array size should be taken or the number of rows or number of columns that will be selected. Now, for ROM, because this is a storage type of thing, so here that for a particular inputs or number of inputs, that all possible output address lines should be there. That means, if it is a n variable, we know that if it is for a n variable function or n input you can tell, then this all 2 to the power n, all 2 to the power n products, or this time this means that all this is the for n inputs, this is my that for n addresses, that many places are there where either 0 or 1 is kept. So, these n variable, or we can tell that address lines. So, for n address lines, there are 2 to the power n such places. Now, size doubles for each additional input. Why? Because so for each additional input, that means it will be, as it is for n, it is 2 to the power n. For n variable or n input line, it is 2 to the power n. For n plus 1, it will be 2 to the power n plus 1, means 2 to the power n into 2. So, that for n variable, what will be the, or for input lines, what will be the size of the ROM, and then for n plus 1, that means if we increase only one additional input, then the size will be double. So, this is the one of the disadvantage of the ROM, that means size is too large. Now, the advantage of PLA. Say already, if already we have seen that the both the AND plane and the OR plane that can be programmed, and a few min terms are used, and many min terms are shared among the output functions. Already we have seen that only that product terms which are available or the min terms of the function, product terms which are distinct and necessary for the design, only we will select that many number of rows, in the AND plane, and in the OR plane, this is in the AND plane, and in the OR plane what we have seen, that in the OR plane also from these number of rows or this many number of product terms, that output lines can share these min terms. Already we have seen. So, that many min terms are shared among the output functions. So, this is the advantage of PLA. So, that PLA size can be minimized, but the ROM size, that memory, that is always fixed. So, that ROM size, that what we have seen, see that if it is a ROM, then for that n address lines, that this will be, the decoder will be a n to 2 to the power n decoder. So, if we write for ROM, that, or what will be the ROM size? Say this is the n address lines, or sometimes we call this is the bits, address bits. So, this will be the decoder is, so decoder is that n by 2 to the power n, and this memory array, that will be 2 to the power n by m, where that m is the output. Now, this is fixed. So, this is the maximum that for n input lines, that number of, this is the n columns and 2 to the power n rows, and this is m columns. So, the if we see the total design structure, then this will be the, this is my size. We cannot, because all the, this is read only memory, that means as if all the contents for all the places that is kept, and mainly we are selecting the addresses depending on my output. Whereas, that for PLA or PAL, that is for PLA or PAL size, that this size, that input lines are, these are 2n for any n variables, this is m outputs. So, this is 2n plus m, 2n plus m columns, and rows will be the only the p number of terms, where this p is very less than the 2 to the power n, because in real life from these all possible product terms 2 to the power n, these are all possible product terms from 2 to the power n, only a few p product terms are used. So, this is my size. So, in real life always the PAL or PLA are advantageous than ROM design. Another thing is that PLA is more programmable, because here the OR and the AND plane and the OR plane both are programmed, AND and OR plane. Here the AND PAL, only the AND plane is programmed, but the not the OR plane. So, here this PAL, PLA and ROM can also be used for design. Now, we see that the one quiz question for this lecture 20. This is design a PLA which realizes the following set of functions, and this is the 4 output functions, that W is A B C bar D bar plus A B bar C plus B C plus A D bar, X is A plus B C bar D, A B bar C bar D, Y is B C plus A C bar plus A B C bar, Z is B C bar D plus A B bar C plus A B C bar D bar. So, these are 4 input variables are there and 4 output variables. So, this is one we have to design the PLA which realizes these 4 output functions. This is a quiz for this class. Thank you.